we can use similar triangles to help us measure tall things. So triangles appear in nature every day, everywhere. For example, if you see Stonehenge, we can see that there are some triangles there. We're going to be using some natural triangles to help find the heights of really tall objects. And the stones at Stonehenge are extremely tall. So if we see this triangle, for example, you could create a similar triangle with a meter stick. And it'll cast a shadow at the same angle that the stone does, as long as you do it at the same time of day with the sun coming in. And we have our sun coming from this side. Here's our sun shining over here. You can't see it on the picture. It's there. And how would you use these two triangles to find the height of this large stone? Well, if I have a meter stick, I know that the meter stick is 1 meter high. And I can measure the shadow that that meter stick casts, and it casts a shadow that is 2.8 meters long. And then I can go and I can measure the shadow that the stone casts. And the stone casts a shadow that is 18.2 meters tall. And now you can see that we could actually set up a proportion to solve for how tall this stone is. So my proportion would look like this. I'm going to take the object's height over its shadow length. So the large object, we do not know how tall that large object is, but we do know that it has a shadow of 18.2 meters. We also know that the small triangle is 1 meter high and that it has a shadow of 2.8 meters. So as we look at these proportions, we know that 18.2 are cross products. 18.2 times 1 is 18.2. So we're going to need to divide that by the 2.8, and the answer becomes 6.5. I know that 18.2 is 6.5 times larger than 2.8. And if that is 6.5 times larger, I also know that the answer then to my height will be 6 5/10 meters tall. That's how tall that stone is. We can use this system to find the heights of all kinds of things. Flagpoles, trees that we can't get to the very tippy top of those branches, a very tall wall like the wall of the school building. If we were in Paris and we wanted to measure the height of the Eiffel Tower, we could do that as well with the shadows. So we want to let's find the height of the flagpole. There's our flagpole out there, and we don't want to have to climb it. So notice we pick a very sunny day. We got a sun shining up here. It's a sunny day, and that sun is going to cast a shadow headed this direction. So we have a similar triangle here that we can use. That similar triangle, we are going to make it 1 meter high. I'm going to hold that meter stick parallel to the flagpole, and I'm going to then see the shadow. And as long as I do this at the same time, I'm going to measure the length of this shadow, and I will measure the length of the flagpole's shadow. And when I do that, my shadow of my meter stick is 2.5 meters tall, and my shadow of my flagpole is 10 meters tall and 10 meters long. And so we make our proportion. We're going to take our object's height divided by its shadow length. We don't know the height of the flagpole. That's what we're looking for. We know its shadow length is 10 meters long. We know that the height of the meter stick here is 1 meter tall, so we have our 1 meter tall. And we know that our shadow is 2.5 meters long. Solving that proportion, I can easily see that 10 divided by 2.5 is 4. So my missing side is 4 meters when I solve my proportion. So I can measure how tall that flagpole is without ever having to climb it. And so I would like you to, over the holiday, probably it's too dark by the time you get home from school, but over the holiday I'd like you to measure the height of your house using the shadow method. And tomorrow in class we're going to go outside and measure a few things as long as the weather hangs in there for us.